Okay, this video is based on C1, pure maths, and more specifically Surds. So in Surds there are certain rules which must be remembered, and that is root A times root A will equal A. Another thing to remember is root A times root B will equal root AB. And the root of A divided by B can also be written as root A over root B. Another rule, open bracket root A plus root B, end bracket, and then open bracket root A minus root B can be written as A minus B in the equation. Okay. So a few rules, written rules, are surds should be written as a prime number if possible. So a few prime numbers are 1, 2, 3, 7, 11, 13. And you should never leave your surds with a denominator. So surds should never be 1 over root 3, for example. Do not leave it like that. While we're at it, you should always keep in mind squared numbers. Now I would personally recommend learning the first 20 squared numbers. So just quickly remember squared numbers. So the first 20 are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. So they're important figures to remember. So to go through these rules in questions, I'm going to do a few of them, so I'm not going to do them on the side of here. So let's start off with a simple one. Root 50. Well, we're basically looking for the either a prime number or squared numbers. Prime number does squared numbers. So in here I can spot that root 25 times root 2 would be in here, and obviously this here can be split down again, so we're left with 5 root 2. So that's an example of that one. The next one, let's do root 9 over 16. Nice numbers. So following this rule here, we would say that root 9 over root 16, and I know that 3 times 3 equals 9, so that's 3 over 4 times 4 equals 16, so it's 3 over 4. Okay, so let's actually do another one like this, but let's make it a bit more tricky. So let's say 6 1/4. Well, what would that equal? First of all, we'd go, that's equal to, we'd find what this is, the fraction. So we'd make, it's still a root. 6 times 4, that is 24. So it's 24 over 4. No. It's 25, sorry. 25, yeah. 25 over 4. Not sure if that looks good on there, but it's 25 over 4. Take that down, that'll be 5 over 2. Okay, so we're basically just messing around with fractions on that one, looking for roots like we did with this. The next one, 4 plus root 2, 4 minus root 2. Well, we're essentially just following this rule here. So we can instantly just say that that is equal to 16 minus 2, which equals 14. Let's play around with this one again, and let's make it different numbers. So this time I'm going to say we have 2 add root 3 and 1 minus root 3. What would you do in this situation? Now, because a is different in this, a is not a constant, we would have to use, well, I personally use the FOIL method, which is the first, outer, inner, lasts. I know some people use the face method, never quite understood that personally. But whatever method you use, as long as it gets the job done at the end. So we'd start 2 minus 2 root 3 plus root 3 minus 3, and as you can see, it does not equal like the first one that we done. It does create something different. That's why it's important to go through it. So next line down, we'd say that that equals minus 1, and that would equal minus root 3. And just to tidy that up, we could do an equals minus sign 1 plus root 3, just to make it a little bit tidier. That isn't necessary though. Now, another thing that isn't mentioned so much in the mark scheme, but is used a lot in the exam, is things with denominators. That's why I've put it above. You should never leave your surds with a denominator. So let's just make it 25 over root 5. What would we do in this case? Well, we'd rearrange the equation to make 25 over root 5 times root 5 over root 5. Okay, now next line down, we'll find that this will turn into 25 root 5, and this will turn into 5. Okay, so the next key thing to remember is that whole numbers deal with whole numbers and surds deal with surds. So when you have a subtraction like this, so the surd will be left alone as there's no other surds to be divided by, but the whole numbers can. So what we're left is 5 root 5. Okay, so whole numbers deal with whole numbers and surds deal with surds. Now, the final one I think I'm going to do, because I'm running out of paper on this page, just to get my point across with this one, is, I don't know, 1 over root 3. 1 over root 3. So what would that equal? That will be equal 1 over root... let me just rewrite that. Doesn't look very nice. 1 over root 3 times root 3 times root 3. Okay. So that would equal root 3 over 3, which is an acceptable answer because the denominator is not a surd. So that's basically it for surds for C1. Yeah.